Hello everybody, this will be your first opportunity to earn a couple extra credit points in our class. The rules are simple. We're going to work through a problem, and at the end of the problem you'll see that there must have been a mistake somewhere. Your goal is to find the mistake and email it to me, and if you're one of the first 5 students of the semester to do so, you earn 2 extra credit points on your exam. This is just a little opportunity to play with some algebra that we're going to learn later in the semester, and get a taste of what my handwriting looks like, which is something you might have to get used to. So, the problem is simple. Assume there exist 2 numbers. Those 2 numbers we'll say are a and b, and we're going to assume they're equal to each other. So a equals b. And for simplicity, we're just going to say a equals b equals 1. They're both equal to 1. So with the knowledge that a is equal to b, it's clearly true that a squared has to be equal to b squared, as squaring something does not change the initial value. And since a squared is equal to b squared, if we replace one of the 2 a's with a b, we know that b squared is equal to a times b. b squared is equal to ab. And the last fact we need for this problem is clearly a squared is going to be equal to a squared, as a is equal to a in all cases. So, one thing you learn in a regular algebra course, one thing that you learned at some point in your life, is that if we have 2 different equations, namely this one and this one, we can add them together, subtract them, multiply them by each other, and we still get a useful equation. So my equation stays balanced if I subtract 2 equations from each other. And I get, in this case, b squared minus a squared on the left-hand side is equal to, well, the first one minus the second one, ab minus a squared. And so I get a new equation. And you might recognize the left side of this equation. This is something that you see a lot when you're first learning how to factor, because it's a rule. It's set up for the rule that when you have 2 things squared, subtracted from each other, or like b squared minus a squared, you can separate them like this. You can say this is equal to b plus a times b minus a. And then on the right-hand side, in an easier way, to see at least, we have the ability to factor here too, because that both terms have a's in them. So I can take an a out, put it on the outside, and say if I take 1a away from this piece, I'm left with a b, minus if I take 1a away from this piece, I'm left with 1a instead of 2, and I have this. But now we see that we have a b minus a on both sides. So in an equation, if I want to, I can add both. As long as I do the same thing to both sides, I can add, subtract, multiply, or divide whatever I want. So I'm going to divide both sides by b minus a, which is going to give me, on the left-hand side, I get just b plus a, and on the right-hand side, I get a, and that's all that's left. So we have this. But what was our initial assumption? We initially assumed b was equal to a, and they were both equal to 1. Well, if I plug 1 in, b is equal to 1, a is equal to 1, a is equal to 1. 1 plus 1 equals 1, or 2 equals 1. Clearly, we all know 2 is not equal to 1. There must have been a mistake somewhere in that problem. Find the mistake, email it to me, and earn your first 2 extra credit points before the class even really gets started.